Okay, so the next problem says, is WVS congruent to angle S? So WVS, and this is angle S. And I would say yes, because the opposite sides are congruent. So because the opposite sides are congruent, by the isosceles triangle theorem, that means the angles are congruent. So those two angles are congruent. And then for the second part, it says, is segment TR congruent to TS? So here's TR and here's TS. Well, since we were given that R and V were congruent, and we showed that V and S are congruent, so that means R and S are congruent. It's transitive. So angle R is congruent to angle S because of the transitive property of congruence. Basically, you cut out the middleman. If all three are congruent, if S is congruent to V and V is congruent to R, then S is congruent to R. Okay, so I cut out the middleman, and now that I know these two angles are congruent, I can say yes, TR is congruent to TS, and this is by the converse of the isosceles triangle theorem. Okay? Converse of the isosceles triangle theorem. Alright, now the next theorem says that if a line bisects the vertex, remember bisects means cut in half. If a line cuts the vertex of an isosceles triangle in half, then the line is a perpendicular bisector of the base. In other words, this is a 90-degree angle, and this little side here is congruent to this little side here. That's actually a lot of information, okay? So let's use that information to solve some problems. So I am asked here, what is the value of x? Well, I notice that ABD and CBD are congruent. These two little angles are congruent. That means that this line is the perpendicular bisector of the base, and it means that this angle is 90 degrees. Okay? Also, since the sides are congruent and this angle is 54, this angle must be 54. So now I have everything I need. I know that one angle has a degree of 90, and I know another has a degree of 54, so x is going to be 180 degrees minus 90 degrees and minus the 54 degrees. So altogether I get 36, I believe. Double check my math and make sure that's right. So let me kind of outline the steps for you again. Okay? First of all, we knew that DB is a perpendicular bisector. So DB was a perpendicular bisector. And that meant that we knew we had a 90-degree angle, so we had 90-degree angle. And also we use the isosceles triangle theorem. If this is 54, because these two sides are the same, this is 54. And I know those two sides are the same because it's isosceles. So then we found our missing angle, which happened to be 54. And then we took the 90 and the 54 that we found and subtracted from 180, and that gave us x. Okay? Now, it says, suppose the measure of angle A is 27. What's the value of x in that case? Well, I'm going to draw a new picture. So let me do that. Here's a new picture. And A is 27 degrees. This is still a perpendicular bisector because, that cuts it in half. And this time I want to know what x is up here. Well, if this is 27, that means this is 27 because these two sides were the same. If the two legs are the same, the two base angles are the same. These two sides were the same, so the angles were the same. So this was 90 because of the perpendicular bisector. So I have 180 minus 27 minus 90. And I think if I did everything right, that's going to end up giving me 63. But please double check my math because I may have made a boo-boo. You never know. Okay? So hopefully you found that helpful. Last thing here, if a triangle is equiangular, it's equilateral. In other words, if it has 3 equal angles, it also has 3 equal sides. And if a triangle is equilateral, meaning it has 3 equal sides, then it's also equiangular. So you could almost write that as an if and only if statement, you know. Anyhow, that is the last of the theorems that we have to deal with. I'll do just a couple more examples for you, and then you can go on and do the Math Excel and then start the next section.